Good afternoon, everyone. Welcome to this afternoon's training session. Today, we're going to cover off the Haldex air disc brake product. We're from SAF-HOLLAND and Haldex merged a few years ago. So we're going to cover a little bit of both, but it's mainly Haldex calipers we will cover here for air disc brakes. Some quick introductions. My name is Tony Ryan. I'm the Technical Services Manager here at SAF-HOLLAND. To my right, your left in the little screen, I know I'm presenting, but is one of my service guys, Ronnie Hines. We have two other service guys that I think are actually on the call as well. We've got Kyle Henson and Ben Dartes are on there as well. So a little housekeeping thing. This is supposed to be as interactive as possible. So if you have questions, we'll have time at the end, but feel free to pop it in the chat while we're talking about it. Or even if you want to unmute and ask while we're going through something, you're more than welcome to do that. If we get time at the end of the session, we will run through. We have a display stub axle and caliper and hub and rotor sitting here in the room with us. So if we get through it quick enough, we'll quickly dive into that and we'll show you some little things on the caliper. We'll walk around with the camera and show you some things there. So hopefully that'll help you as well. So, all right, let's get into it. So first things first, I mentioned SAF and Haldex have merged together. For the time being, we're still running it as two separate websites. So the Haldex stuff is on www.haldex.com. Most of the stuff we're going to cover here is mentioned in the technical manual for the Module T caliper, which is L30051 document. You'll find that on haldex.com, and we'll run through some more as we go through. All right, so a basic operation principle, I should say. It's a monoblock caliper. For those of you who were around the first time North America tried to go to disc brakes, they were a two-piece caliper, which meant there was a bunch of bolts that held the two halves together. This current generation is not like that. It's a single casting, just with some assembly and inspection holes through the caliper itself. So it's one big casting, so there's no bolts that can come loose or anything like that. The adjustment unit is actuated by a mechanism lever, which is A, there on the bottom left-hand side. Essentially, that lever is what you would know in drum brakes as a slack adjuster. It's a little short, stubby version of what a slack adjuster does. It actuates forward and back, and your adjustment is behind that itself. That then pushes the piston and the backing plate onto the brake pads, onto the inner brake pad. It overcomes that resistance and then pulls the outer brake pad across. Okay, so there's a bunch of little pieces in there that I mentioned. The brake pads are B, the caliper itself is C. The inner brake pad is B and the outer brake pad is D. And then on the right-hand side there, you've got F as the brake chamber and E is the slide pins or guide pins, depending on what you want to call it, same thing. You'll notice that the top guide pin is longer than the bottom guide pin. That is deliberate. The reason for that is the first guide pin in direction of rotation, the first one the rotor will hit. And I get my mouse to work. So if the rotor is spinning around this direction, it comes in. The first one it hits is the long guide pin. Just gives it a little more structure. It means that things don't bend, flex under braking forces as needed. So the long guide pin is always the first in direction of rotation. Okay. Now, given North America, almost all of the calipers on, at least on trailers and on some trucks, they're all on the back of the axle. It will be the top guide pin will be the long one. If you've got one on the front of the axle, it will be the bottom. Slide. So you've got a caliper comes in, you want some information on it. There's an ID tag stuck to the caliper with a bunch of information. So you'll see there's part numbers and serial numbers, whether it's type or the OEM part number across the top line. Then you've got the part number that we would know it as, and then underneath that is the serial number. So the serial number, first two digits are the year, the next two are the week, and then the rest is the serial number, the Haldex number and the serial number. So you can give that to our service people, our warranty, our customer service. They'll be able to decipher that and figure out exactly what you've got, what you need going from there forward. Inspection intervals on disc brakes. So this is what we recommend for intervals. I know that some fleets will shorten this up and modify this slightly just to match up and marry up with their DOT servicing, and we get that. But this is what we recommend. And I'm not going to go through every line, but there is a before first use inspection. So visual inspection and just checking the guide pins and the thrust plate guide pins to make sure that they're all okay. And then there's a daily inspection, a 3-month and a 12-month inspection on what you should be looking at to make sure that everything is in good working order going forward. So this particular slide, this just shows what they'll look like in the wild. You'll notice they're on the back and generally they're at 9, 10 o'clock or 3 or 4 o'clock, depending on which side of the axle you're looking at. You'll notice they're behind the axle. In each of these, just make sure when you are looking at these, make sure that those hoses aren't too tight like that one on the left, because that can actually affect the actuation of the caliper going forward and backwards. If the hoses are actually pulling on the caliper, that will affect some brake issues as well. And make sure that those hoses aren't rubbing and chafing on anything. With these brake chambers, you can rotate them 180 degrees, and those hoses can actually end up rubbing on the axle, rubbing on the bottom of the suspension trailing arm, and the last thing you want to do is rub holes in the airlines. So just make sure that you're doing your due diligence when you're looking at these out in the field. Okay, the pad wear indicators. I mentioned that there's a lever that acts like a slack adjuster that pushes on a piston, which pushes on a backing plate. This is a single piston caliper. It's not a twin piston or a dual piston caliper. It's a single piston. It has a wide plate that attaches to that piston. It's not a separate plate like some other brands out there. It's all integral as part of the piston. But on each bottom corner of that, there is a little pin that comes back through the caliper itself. And there's actually a mark in the casting. So that will show you basically, do I have 100% friction material or do I have 0 or somewhere in between? It is a amalgamation of the inner and outer brake pad wear, but the reason it says there it's not an accurate measurement of pad wear on both pads, it's assuming that you have worn both pads equally. So if you have excessive wear on a inner brake pad, say you've got a dragging brake or something like that, then that will wear the inner pad faster, and you may get a false reading from that. And vice versa, if you've got a seized guide pin, which we very rarely see on this caliper, but we did on previous brands that we used, then that will drag the outer brake pad and wear that one faster. So it's not out of the realms if you've got a serious failure in there that you could have this pin showing 50%. But one pad is completely worn and the other one's brand new. So just remember, this is a visual guide, and if you want to, we would recommend that you literally just stick a flashlight or something up there and just visually check that the pads are roughly the same worn. If they're not, then pull the wheels off and inspect further. So here it shows the guide pins in their position. You'll see there's one top, one bottom. There is only one measurement scale on these calipers, so one pin doesn't have a scale on it. But they should move very free and unobstructed. The hole is much wider than the pin, so it shouldn't be a problem going forward. This is a little better view of what they look like. It's a much cleaner picture and graphic that you're looking at. And this is what they look like in real life. This is actually the caliper that's here in the room with me right now. This is what they look like in the wild. Those pins coming back through. So it's a visual guide. Once you're under the vehicle on a creeper, you're doing your PM servicing, this is what you'd be looking out for. And this way you can put a digital caliper on there and measure this and record that going forward to keep your records as far as what brake wear you've got on each particular wheel end on each vehicle. So the pad clearance inspection, if you want to check your pad clearance, just to make sure the adjuster is working correctly. This is one part of what you would do for that. you would remove the wheel and tire assembly, cage the brakes, whether you use the caging bolt or you use air, that's up to you. Insert 2 feeler gauges between the caliper and the outer brake pad. Just make sure you shuffle the caliper forward and backwards and make sure all the running clearance is between that outer brake pad and the caliper itself, because that's what you're measuring is the running clearance. And then the measurement you're looking for is between 30 and 40,000. So just remember that it's very simple test to do, but just make sure all your running clearance is in the same spot. Also, just looking at your pad wear inspections, make sure that you measure the friction material or the brake material on each brake pad. So for those of you around in the 90s, they used to measure the friction material and the backing plate, which became horrendously complicated when people went from 6mm backing plates to 7mm to 9mm to backing plates with steps in it, all sorts of complications. And I think it's pretty much universal now. Every manufacturer that does disc brakes just measures the friction material. They don't measure the backing plate at all. 2mm is the minimum you should ever get to. That doesn't mean you should let it go out when it's got 2.5mm. And I'll show you why. There's a picture further on, and we'll show you why you shouldn't get below 2mm. Okay. The other thing is measure the brake pad thickness between the inner and outer brake pad. So the allowable difference is 0.2 of an inch or 5mm, and that's between any measurement between those two pads in the same caliper. Okay, so make sure there's no discernible wear difference between those two pads. If there is, as I mentioned, there may be something a little more sinister in there that you've got to go look at. Root causes, like I said, seats, guide pins, dragging brakes, something like that, depending on whether it's inner or outer brake pad. If they are outside of that, replace the brake pads, but also go and have a look at what the root cause is. The number one thing I'd look at is it on all wheel ends? And more than likely, if it is, that'll be a controlling issue. If it's one wheel end, then you're more than likely got an issue with that caliper. Also, have a look at the brake pads just to make sure they're not only worn different, but they're not worn skewed. So you can see here in the top graphic and then the bottom graphic, you can see they're skewed front to back and then top to bottom in those two pictures there. That bottom one, the first thing I would look at for that, I've seen this on the old caliper where the metal backing plate wore into the carrier and then it dug in, it was deep enough that it stopped from sliding and then it was able to tip it over, but that was just one pad. If you've got two pads like this that are worn, I would seriously start having a look at things like, is your wheel bearings tight? Is there too much end play in that? That could be a cause for that. Top one, I would actually make sure the caliper mounting bolts are actually tight, because if they're loose, then that caliper may be sliding around and not be mounted correctly. So just a couple of things to look at. End to end, top to bottom, 0.078. But yeah, like I said, just have a look, make sure everything is mounted correctly, end play is correct, caliper mounting is correct. There's nothing sinister in there. As far as brake pads, you're allowed some slight edge cracking on those brake pads. You can see on the left-hand picture there where it says permitted. It's a natural cycle of the friction material heating up, cooling down. You may just end up with some slight edge cracking, like in the picture there, that's fine. But if you do get mass lining material disappearing, like in that middle picture there, where it says not permitted, that's not okay. Okay, something is wrong there. So, and I did mention the 2mm minimum of the friction material. You'll see in the very bottom there, you'll see what looks like a little grate underneath the friction material. That is what helps adhere the friction material to the metal backing plate. Some manufacturers will put a little metal grate in there. Some will gouge little curls of metal will peel up, almost looks like Velcro. But whatever the method that they use, and that's essentially metal. And if you get below that 2mm, that metal will then start running on the rotor, and metal on metal makes a mess. It becomes a very expensive exercise. So if you don't think it's going to make it to 2mm before the next PM service, change the brake pads. And the one on the right-hand side there, I mentioned about the worn carrier. This one will also worn through the backing plate. So you'll see the big chunk missing out of the backing plate there. But also the big obvious issue here is the difference between the inner and outer brake pad. So I can tell you through experience, because I was the one who looked at this, that right-hand brake pad is the outer brake pad, and this was the C's guide pin on another brand of caliper that we used to use before we bought into Haldex. So yeah, that one was a C's guide pin. So always check, even though you've got those pins on the backing plate on the piston in the caliper, that will give you a rough guide, but a visual inspection to make sure they're worn evenly will serve you well. All right, brake pad compliance. So prior to 2020, you could make friction material pretty much out of whatever you liked. But from 2021, there was a law that came in that you had to have a less than 5% copper in your brake pads. So that went from a 1-leaf pre-2020 to a 2-leaf logo. So you'll see these on your friction material nowadays. And then from 2025 onwards, you'll see the 3-leaf. That had to have less than 0.5% copper in your brake pads. So I will tell you a little pro tip. I don't think any manufacturer out there went to the B friction material. I think everyone went to the 3-leaf N friction material by 2021. But it just saved on 2 lots of R&D to test it twice. So we went straight to them. So we've been using them now for over 4 years. There is a caveat to that. If somebody has brake pads that they've owned for longer than that, it's not a problem. So if you've got brake pads from 2022 that are B leaf pads, that's not a problem. But you're not supposed to sell or buy. We're not supposed to sell customers anything older than what we've got. All right. One thing I did forget to mention at the start of the presentation, I will send out a wrap-up email of all the information here. So you'll get a link to the videos both this morning and this afternoon, this very session. And I will also send out a PDF copy of this presentation. The reason I mention that is on the bottom of the page here. This is a video on this page. There is a link on the bottom of the page there, so you can go and watch it back. So obviously on a PDF, you can't attach videos, but I'll attach the link is in the PDF. You'll be able to watch it back in. So to do an adjuster function test, we're going to release the park brakes and just check the wheels spin. Then we'll de-adjust the brakes, so you basically back them off by 4 clicks, and then you'll leave the T55 Torx bit in the reset shaft. And what I mean by that is, so T55 Torx bit is the tool you use, as opposed to other brands where you use a 10mm socket or an 8mm socket, depending on the brand. Haldex uses a T55. The adjuster, which we call the reset shaft, is very similar to the principle of a shear adapter on another brand of caliper that most people are familiar with, but it's actually sunk inside the caliper by about 1.5 inches. So we call that the reset shaft. It's a plastic piece. I do recommend, if you're using a T55, use a 1/4 inch drive. I use a 3/8 drive here, but it's got a very short ratchet on it. I wouldn't use 1/2 inch with a big long extension on it because you can overtorque. It's a plastic piece. That said, if you do strip it out, you can replace it. There's a kit that you can buy, the reset shaft, the little plastic piece, and the tool to get it out. It's readily available. If you don't have the tool, there is a plan B. You can just use the wire piece in a bulldog clip. Works just as fine. I've done that in the field in a pinch. So I'll show you this video, and there's one in the next slide after it as well, which gives you the second part. Wheel spins, we'll take the plug out. We're going to put the T55 Torx bit in there. We're going to back it off 4 clicks. and then we're going to leave the tool in there. Okay. Then in this next video, we're going to apply and release the brake pedal 5 times. What you're looking for is that tool to rotate clockwise. And what it should do is it shouldn't not rotate, and it shouldn't rotate and then come back. It should rotate, stay put. And that's it's doing an adjustment function. As a pro tip, if you're a technician and you want to check these very quickly, it's a little hard to see all 4 wheel ends if you're on a tandem drive or tandem lazy or a trailer. It's very hard to do that all in one hit, but you can very easily do one side. So just put tools down one side, normally a ratchet down one side, and watch them both move at the same time. Swap them to the other side, do it again, and you can watch those 2 move again. Okay, show you what we mean by that. I'll hit play on the video. So hitting the brake pedal, and you can see it rotates and it doesn't come back, which is what you're looking for. And this is very easy to see underneath a vehicle when you're doing it in real life. So the adjustment procedure, using a T55 Torx, you adjust the brakes by turning the reset shaft clockwise. Make sure it touches the rotor and you feel it stop. Then you turn the reset shaft back counterclockwise. It's 2 clicks. That said, if you do 1 click, you're not going to have enough running clearance, so do it another click. If you happen to do 3 clicks, it's not complicated to start again, but if you don't, it's another brake application and it will adjust itself up. Okay, that said, I wouldn't go 4, 5, 6 and test your luck, but 3 clicks is not the end of the world. Okay, and that will set your initial brake pad clearance. Always, and I need to reiterate this, always, when you do an adjustment, if you have adjusted the caliper all the way back to its bump stop inside the caliper to get the pads out, don't just put new brake pads in and assume it will adjust up. You've actually got to start the adjustment again on that 3. So you may as well go through the rest of the adjustment if you've got to that point. So don't always leave it fully adjusted all the way back. You need to re-engage those 3. So you would need to at least restart that adjustment procedure. There is a reset shaft in every caliper, but if you do need one, the reset shaft kit is listed there. That's 790-95398 is the part number. Make sure that the orientation of the reset shaft protected plug is correct. So on the right hand side here, you want to make sure that that plug is fully inserted, not twisted, half hanging out, and you want to make sure that it's orientated not back towards the bottom there and it's going to hit something, get fouled by road debris. Make sure it's up, pointing up towards the slide pin. And last but not least, do not over tighten the adjuster. Again, it's a plastic piece in there. It's designed to be a sacrificial lamb. So if anyone gets too big and heavy-handed with it, that's the cheapest and easiest option to repair it. You're not going to break all the internals. You're just going to break the reset shaft. So here's a little bit more information on it. So you've got the reset shaft protection plug, A. They're grey in this image, but I can tell you in real life, they're generally bright yellow. The seal is B. You shouldn't have to adjust or play with any of that. C is the slide pin protection cap. Again, I mentioned there's a long and a short slide pin. And then D, this is the one we get asked about the most. This mechanism protection cup, they call it. It looks like a really weird shaped screw with a bit of rubber on the end of it. It's a triangular shape. It sits just under where the brake chamber mounts. We get asked this all the time. What is it? What do I do with it? How do I adjust it? It's part of the assembly process of the caliper. It actually sets the torque on the clutch mechanism inside it. It's an odd shape for a reason. It's made so people don't have the right tool and they can't adjust it. So it's even though it's sitting on the outside of the caliper, as a fleet technician, you don't need to touch that. It's nothing to do with it. You can see there in bright yellow, we've highlighted there that if you start playing with that, it voids the warranty. So it's just part of the assembly process. You don't need to touch it or adjust it or play with it or do anything like that. All right, inspecting the slide pin bellows. All right, so the slide pin bellows, because North America, most of the calipers are behind the axle. It's moderately protected by the axle itself, but essentially it's the shape of a big catcher's mitt. So it can be subject to road debris hitting those bellows or boots, whatever you want to call them. So just check those while you've got the brake pads out, fully extend the boots and make sure there's no tears, perforations, because if you start getting road debris, you get rust and corrosion and they will seize up. So just make sure they're not torn or perforated. The other thing is that as you're pulling and pushing the caliper, you don't be surprised when you see them, what they call suck down or by like a vacuum, or when you're doing it the other way, they'll balloon out. That's because there's a very tight tolerance between the slide pin and the bushing that holds it in place. But if you were to hold it, say, ballooned out, give it a couple of minutes, that air pressure will equalize on the other side of the bushing and it will settle down. So don't be too alarmed by that as well. But if the bellows are damaged, they need to be replaced. The other thing I will show you is, this is a reasonable graphic here. This is the backing plate. You can see in this top right image, and the piston itself, the backing plate actually extends and becomes the piston and it sits in the body. So the boot is actually way inside there. And only when you are at about 10% brake pad, somewhere around there, will you actually start to see that rubber boot. It's really well protected and tucked away in there. So that's one less thing that can be hit by road debris, one less thing the technicians actually have to look for. The other thing you're going to do is just check the slide function, do an inspection on that. How do you do that? Pull the brake pads out and just slide the caliper forward and backwards. Do a full travel forward and back and just make sure that it's not jamming up in any way, shape or form. You haven't got any clumps in there, like it's got a groove in the bushing or something like that. Make sure there's no issues there. I've seen customers do a very quick check without taking the wheels off, just pull it forward and back, but you're only checking the amount of running clearance you've got between the pads, which isn't a great deal. So the ideal way to do it is wheels off, pads out, and just slide it forward and backwards. And they should both slide freely on both pins. The other thing you're going to do is check the bushing on the slide pins, what they call inspecting the bearing plate. Essentially, you're trying to twist the caliper. So you're pushing on in this case, we'll go with the red arrows first. You're pushing back on the brake chamber and you're pulling forward on the front of the caliper. And then you do it the other way around, which is the black arrows. And you put a dial indicator and you just double check the wear in the bushings. So if the bushings measure over 80 thou, that's when it's time to run a kit through that or replace the caliper. Rotor inspections. This one here is a bit of a funny one because the brake pads don't ever run all the way to the top of the rotor. So you'll always end up with a little lip, which is shown in the graphic in the top right here. There's always a little lip. So you need a caliper with some extra measurement on it to measure rotors. You can't get a standard digital caliper to do it because you won't be able to get around those lips on the rotor. So you need a special set of digital calipers to do it. That said, you can always get two spacers, two washers or something like that, and then measure it and go from there. Measure the washers put together and then measure the rotor and do that. That said, in today's day and age, most rotor manufacturers actually have a visual guide as to the rotor itself. So I know on our European rotors, they have a beveled or a chamfered edge on it. The rotor that we currently use has a big pronounced step in it. And I can tell you after many Michigan winters, I've looked at vehicles on the road here and that stepped edge is still plainly visible. And if you've got to a point where you think, hey, this one might not make it back to the next PM service in 12 months' time, it's probably time to replace that rotor because the repercussions of not doing that are going to be way more expensive. So always remember that as well. And if you do get rotor thickness variance, 0.12 millimeters or 0.005, just think of that 5 thou in there. Just that's a measurement variance we use as well. Torque tightening. Now, this is what we recommend. I would thoroughly recommend going back to your OEM, whether that's a truck or a trailer OEM, and just double check what they are. On the trailers, we use them on our SAF axles, and we can tell you what the recommendations is for that, but the bolts are all supplied by the OEMs generally. So we know what our bolts are. They're a 24 millimeter 12-point socket, and we know what our measurements are for that particular bolt size, but double check with your OEMs as far as what the tightening torques are as well. All right, some rotor inspections. Here's some of the things you'll see out there. So some light heat checking on that picture on the left-hand side. That's perfectly normal. That's part of the heat cycle of hot, cold, as you hit the brakes and cool down. So that's the metal expanding and contracting. So light heat checking is perfectly normal. Some heavy heat checking is generally okay until you get to a point where those cracks, any of those cracks are over 60 thou, wide or deep, or they extend over 75% of the surface distance of that rotor. I will tell you that if you've got 75%, I'll almost guarantee you it will hit an inner or an outer edge, which is critical to make sure that it replaces the okay, so this one is just looking for grooves. Normally when we see grooving on a rotor, again, it's the same measurement, 60 thou. But when you see it, what you're looking for on a rotor, it will normally be on the inner side of the rotor. The outer side is generally pretty protected from road debris by the rim that's sitting on the outside of it, but the inside is fairly exposed to road debris, and that's normally what the root cause of grooving is. There's something being jammed in there. If it's a singular deep groove, there may be a rock has jammed in there at some point. It may have come out somewhere. It may not still be in there, but if it's lots of little grooves like this one, it's normally road debris. Whether it's you're in the northern states of the US or Canada, and you're running sodium chloride salt on the roads, or you're running in a dry, dusty, sandy environment, that can also be another scenario for a root cause for this. So if you get this on an extended issue, it may be something you're worthwhile considering running rotor shields on these, just to make sure you can keep that road debris out. Another rotor inspection to look at is you're looking at discoloration. So at high temperatures, you'll get some blue marks on the rotor when it started to get up in the heat cycles. So normally they're a shiny silver color. If you start to get blue marks, you've had an excessive heat cycle run through it. This is generally not too much to worry about. It's something to be alert, have a look at, make sure there's nothing sinister about it, but it generally tells you that there's been a start to a heat cycle in there. Now, is it a one-off where a driver drove down a long hill? Possibly. Is it something that it could be a dragging brake or something more sinister? Yep. So just do your due diligence as a tech, just to make sure everything is working correctly. It's not horrendous. Normally they go black after that when they've got really hot. And then if they get even hotter, you can get what they call martensite spotting. So you'll see on the picture on the right-hand side that I took a year or so back, you'll see martensite spotting on the rotor on the right-hand side there. Almost looks like leopard print or something across the rotor there. That's little bits of friction material that have embedded into the rotor. So it's little highs and lows, but it's friction material that is heated up and stuck to the rotor. Okay, so just double check that as well. In that case, you can probably burnish them off with some emery paper or reface them, but it's up to you whether you want to replace it or not. And this is what it looks like up close. It's just high operating temperatures, little bits of lining material stuck to the rotor itself. So again, you can resurface, which is not something I see done here in North America a lot. But you can resurface with some emery paper or resurface with a machine. Another one is rotors exhibiting like a mirrored finish to it. this picture isn't the greatest, but you can see there, generally it's a lightly dragging brake. To correct this, you got to polish it, sand it, make sure you get rid of that polished surface. You can get back to the metal, make sure it's not all polished and shiny. So you've actually got something for the friction material or the brake pads to grab hold of so they can do their job naturally braking. This graphic here, this is not an SAF-HOLLAND graphic. This is a universal graphic. So it doesn't matter whether it's USA, Canada, Europe, Australia, whether it's us, our competitors, even TMC uses this particular image here. So it's the same information across the board. Area A, we already covered. That's some light spider cracking. That's just some heat checking. Perfectly normal, not a problem at all. Area B, 60 thou cracks, whether they're over that width or depth, or if it's over 75%. Experience tells me that you'll probably never come across that, because by the time it gets to that point, it will be area D, which we'll get to in a minute. Area C is radial grooving, which we mentioned is normally a byproduct of road debris getting up in there. Again, if your radial grooving is over 60 thou, resurface or replace. But area D is the one that most likely seen is when you get a crack that extends to the outer edge. So if you get some reasonably good cracks in the rotor face, generally they can work themselves out. They'll wear the rotor down and it'll wear itself out. But once you get to the inner or the outer edge on that particular rotor, my mouse wake up. So the inner edge here or the outer edge here, once you get to those 2 points, it's a point of no return. So that rotor needs to be replaced once you've got to that point. Non-genuine and will fit parts. So this picture on the left-hand side, I took this a few years back. This particular customer bought one of our trailer axles and had perfect wear on it, good mileage, everything ticked the box. He was very, very happy with the product. He did his first brake pad change, put will fit brake pads in, and this was the result. So have a look at the black color of that rotor, and you'll see that has seen a significant heat cycle through it. And it got to the point where it's actually cracked that rotor all the way through on both inner and outer sides of that breather fins through the middle. So that rotor had to be replaced. The end story of that is the caliper that we usually use for SAF-HOLLAND trailer brakes also has a sister company that does truck brakes and calipers. They used a will fit brake pad from that manufacturer because they were easier to get hold of. That particular brake pad wasn't a over-the-road trailer or even truck brake pad. It was a high-duty cycle designed for garbage trucks, and that generates so much heat. This was the end result. So again, we recommend not bringing will fit pads. Just make sure that you've got the right pads for the right job in there. Okay, brake chambers. So when you're going to mount a brake chamber, just make sure you've got a correct brake chamber in there for disc brakes. So you'll see here on the left-hand side, whether it's 20 millimeters, the push rod extends, and whether it's 15 millimeters, the push rod extends. That's correct. If you get someone who's managed to jerry rig and make up a disc brake chamber out of a drum brake chamber, the strokes are actually different. So that's why the push rod will probably stick out a little bit further. Okay, so you'll see that the stroke is wrong, everything is wrong on those brake chambers. So the other thing is when you are putting the brake chamber on, a couple of points to note. One, just put a dollop of grease on the end of the push rod where it sits in the cup. It'll just allow it to slide a little bit easier. That is the only point you'll actually put grease on this caliper. Everything is internal. So there's no grease zerks, nothing you need to do. Nothing you need to check, anything like that, which is good for any company who has an environmental policy as well. That's no grease in your slack adjusters, no grease in your S-cams or anything like that. The other thing to make note of is don't just put the mounting studs through the caliper and use an impact wrench to tighten the nuts up. do one up and then do the other one up, you'll twist the brake chamber sideways, and you may have issues with mounting that cup correctly. I've seen this once before where someone has done that, and somehow I couldn't replicate it. They managed to get the push rod in the brake chamber above the cup, wedged between the cup and the housing in here. So it's a one-off I've seen, but make sure that you do them up just little bit by little bit, both nuts up so that the brake chamber is mounted square and nothing weird, wacky goes on there. So, all right. So this slide here, I know it's a little bit of an eye chart, and I'm not going to dwell too much on it, but this is something I did when we worked at SAF-HOLLAND in Australia. I want to just give you some information so you put the right part in the right application. So a drum brake 30-30 is a 30-30. They're the same between brands. And useless fact for those of you who don't know, the number 30 on a brake chamber actually is the square inches of surface area on the diaphragm. So the first number is 30, which is 30 square inches of surface area on the surface diaphragm, and the second number of 30 is the park brake diaphragm. So between brands, they're so close, the force output is minimally significant. It's so irrelevant, it doesn't matter. This one here, I just want to bring your attention to, so a 1216 was something we used in Australia a lot. 943 newtons was the surface output. There was another brand that was type 15, so 3 square inches bigger, and it actually had less force output. What does that mean for you? If you start mixing and matching brake chambers between brands, you can end up with different force outputs, which means you can end up with torque steer. If it's on a steer axle, it'll be very prevalent, you'll know it. Or you'll end up having mismatched braking on a drive axle or a trailer axle. As always, we say to people, put the right part on the right application, because you won't know until it comes to an issue. And then when it does become an issue, the wrong people start getting nosy in the wrong places and start to go, why did you put the wrong part in there? So it's best to just put the right part in the right place rather than a will fit, because you can end up with issues. All right. Again, we do have the option here, and I think we're actually a little bit ahead of time here. We do have the options for some questions. So if you've got any questions, feel free to type it into the chat. But I'm going to run through a couple that I do have pre-made here. How many clicks to back off the caliper adjuster to make the running clearance correct? 2 clicks. Now there are other caliper manufacturers out there that are 3 clicks. This one is 2 clicks. What causes marked site spotting? Heat and temperatures. When was N3 leaf friction material required, signifying less than 0.5% copper? 2025, I know from SAF-HOLLAND and Haldex, we were already there by 2021, so we were ahead of the game well and truly. What's the minimum thickness of the friction material in all SAF-HOLLAND brake pads? 2 millimeters is the minimum you should see. So if you see 3 millimeters, don't go and send it out and say, yeah, it'll be back in 12 months and it'll be under 2 millimeters. It should never see under 2 millimeters. That means that those metal grates or the curls that they have in the back of the plate will end up gouging into the rotor, and it'll be a much more expensive exercise, because unlike drum brakes, where you used to get 2 sets of shoes and linings to a drum, and now you only get 1-to-1, with disc brakes you'll still get 2-to-1. So for each second pad change, you'll have to change the rotor, but you'll get 1 pad change where you don't have to touch the rotor at all. And are disc brake chambers interchangeable between brands? Ideally, no. Different force outputs. We don't want to have torque, steer, and wear difference issues going forward. All right, I see one question. It's from one of my guys. So thank you, Kyle, for being the first to ask a question. Is there a tool to measure brake pad thickness with the wheels mounted? So you can measure it off the pins off the back of the caliper. We did have a tool for our previous brand of caliper, but this one you don't need a tool at all. You've got the pins on the back of the caliper, and there will eventually be a what they call it, the electronic device that will go into the adjuster and will be able to measure the brake pad wear electronically going forward. All right, is it recommended to to surface the rotors between pad replacements? That's entirely up to you. I haven't seen the need for it up until now, so that's perfectly fine. Thank you, Douglas and Zachary. Are the caliper bolts supposed to be replaced post-removal? We say absolutely yes, because they are a torque to yield bolt and they are a fairly high torque bolt. So yes, we thoroughly recommend that you do that. I know that, I'll give you an example. I know that our manuals have both Newton meters and foot pounds in it. And if you get those two confused, you will actually tear the head clean off the bolt. So there's not that much room to play with. So I would thoroughly recommend that they get replaced every time. To that end, what we've done to counter that, to take that choice out of customers' hands, is in our world, in SAF-HOLLAND's world, you can't buy a caliper. You will actually buy a caliper kit that will come with the box with it. All right, how are we doing for time? Yeah, we've got about 14 minutes left. So, all right, any last minute questions? Otherwise, I can fill up some time. So for technical support, we have the Haldex number. Haldex has still got their own numbers and their own customer service people for now, but generally we're integrated, but we're running separate websites, separate phone numbers. So that's the technical support for Haldex. On the website, you'll have literature, videos, training products, etc. The website, again, is on the bottom of the page there. If you do need further help, there's me and my team. As you've already seen, that's myself, Ronnie next to me. Kyle's already asked a question, and I'm sure I think Ben's in the room as well somewhere. And then if you do need further help, because we tend to be out traveling on the vehicle, so we're not always accessible at all hours during the day. If you do need further help, you can call either SAF on the number on the left-hand side, hit 123, or their service at safholland.com. We'll take you through to our warranty department. And then on the Haldex side, you've got the 800 number with 1, 2, and 4 as your options for departments. And then you've got Haldex.warranty there as well, that you're able to get a hold of through there. They have an SAF-HOLLAND email. They're still running their own website for now. All right, so that's all I have for that. But what we are going to do, because we're actually a little bit ahead of time compared to what we were earlier today, I'm going to stop sharing and I'll change the no, I didn't get it. So for everyone, what's the button? Say yes. There we go. Done. You want to go and disconnect the camera? Ronnie's going to be my cameraman extraordinaire. Okay. Just have to look over your shoulder and try not to shake the camera around too much. Everyone will get seasick. So I mentioned the tool that I use. This is the T55, very short, stubby end, very short because it's 3/8 drive. Make sure that you don't get too much torque in it when you're doing your adjustments. Okay, so to do a brake pad change, you pull the plug out. You see it should be yellow. This one's had a very hard life. It's not overly yellow anymore, but it is certainly still there. Pop that in. Okay, and I can't go any further because that's going to adjust it. That's hit the bump stop. I can feel the pressure's changed in that. All right, so we're going to take the brake pads out. We're going to push this spring clip down and take the pressure off here. So this spring clip literally just pops up in this hole and stops the retainer bar from being able to fall back and the pads coming out. Okay. So pop that down. We're going to push down on here. This is held under the horn here. Push down, take the pressure off the brake pad springs, and then push this back. Okay, and that comes out. That easy. Okay, now in this particular caliper, you've got to pull. All right, you got to pull the outer one out first. Okay, and then you pull the inner pad out. The reason being is both of the brake pads and they are universal brake pads, inner and outer. They're exactly the same. Okay, there's no inside pad, outside pad. There's nothing like that. But these two little dimples in here, they do align with the two little dimples inside the pressure plate here. Okay, so if you were to put the outer one in first, you literally won't get that inner brake pad in. We mentioned before, just checking the slide, make sure these work okay. Push them back. You can see the vacuuming we were talking about on here where that's sucked itself in. And then if I do this right, it's not quite going to do it. You probably won't be able to see it, but the one on this side is actually the opposite. It's actually ballooned up, but it's only just starting to do it. Okay, so just check those are okay. There's no tears or perforations. There's no excessive marks or grooves in the carrier itself. Okay. One thing I did promise to do, if you want to keep coming around from this side, Ronnie, I'll wind this in. Okay, you can see how far that has come out, how far your brake pads will have left, and you can just start to see there is the boot in there. So that's one less thing you have to worry about as a technician, has that that boot being torn or perforated, because you essentially, by the time it gets to that point, you shouldn't be able to see that boot anyway. That's hit the end there, so I can feel the pressure stop. Now, if you wanted to at some point, if you ever want to check these, you could, if you've got the brake chamber off, you can get a screwdriver or a socket extension or something, push on that, that lever, and then watch these move. And this is how you would check the adjuster in the field. Okay. Popping the brake pads back in. Again, we're going to put the inner brake pad in first. Okay. Now, one thing I do want to show you, Ronnie, if you want to just zoom in here. Okay, you'll see here, I haven't pulled this caliper across yet, but the backing plate, I have seen this once before, where someone in a Supertech competition did that, and they actually got the backing plate jammed behind the carrier. You'll see the massive amount of clearance you've got there. Obviously, you want to avoid that. So just make sure when you put them back together, they're in there correctly. So like that across. And you would have felt that just engage in that. Plugged in. This is the retainer bar. Plugged in under the back pad there. And that's it. That's how easy they go back together. Worst case scenario, if you've got one that's old, obviously this is a display, but if you've got one that's old, you can pop that down and you can use a screwdriver in here just to pry that back. But that's probably the best tool you will need. And then to do an adjustment, and you feel that just re-engage. That's why I said you don't ever leave that all the way backed off. Felt that engage, button that up, and 2 clicks. Okay, and if you really want to be doubly cautious, we can grab the caliper and feel. Like if we were to go and do that measurement we mentioned earlier, make sure all of your clearance is here. Go and get your feeler gauges and pop down there. You can measure that. So that caliper's, the piston is on the pads, which is on the rotor. This side of the rotor is on the pad. All the clearance is here. You can get those feeler gauges and run those through there. Okay. As I mentioned, the reset shaft is all the way down the bottom here. So you can see it's, you know, what's that, inch and a bit, all the way down the bottom of that hole. So you can use a bulldog clip, just a wire out of a bulldog clip to pull that out and pop the new one in. If you just have a reset shaft, if you don't have the tool, fairly simple, but it's an easily replaceable part. This is the weird shape piece that I was telling you about that you don't need to touch. That's why it's a weird shape, done like that for a reason. And then as a last resort, just make sure that you pop this in. Like we said, make sure it's popped all the way in. It's facing towards the long guide pin. Don't face it down towards the rest of the axle. Always double check your mounting bolts, make sure they're tight. There's no issue there as well. And that should be it. It's fairly simplistic. You've gone and checked your adjuster, you've checked your guide pins, you've checked your boots, you've done a full inspection. You know you can send this one out the door and it's not going to be an issue going forward. Okay, All right, we'll put the camera back running and we'll just double check, see if there's any more last minute questions. Little, keep that's all right, we'll deal with it. All right. Cameraman extraordinaire. So, all right, so we're pretty much on time, folks. Any last minute questions we've got? Now would be your time if you want to type it into the chat, or if you want to unmute yourself. It's entirely up to you. I will put the contacts page back up for you. You have the contacts page as well. Any last minute questions? Going once, going twice. Anyone typing? All right, well, if that's it, I will give everyone back a couple of minutes in their day. Thank you for everyone attending. I will send out a wrap-up email of this particular session and this morning's session as well. It'll likely be tomorrow sometime, if I get a chance. If not, it will be Thursday. And you'll get a copy of this PowerPoint presentation as well as the links to each of the two recordings as well. So you'll have both of those as well. So if you need anything else, feel free to give us a holler, send us an email, text, give us a call, whatever. There is also a one more session we have tomorrow afternoon. I think that's 2 p.m., which is a drum break session as well. We already did one this morning just before lunch. So if you want to be in the drum break session, you are more than welcome. If you want to, just add your name to the chat, or add your email, I should say, to the chat. Or you can send us an email, just take a quick screenshot of what you've got on the screen now and send us a note, and I'll forward you the invite. You can be a part of that. It's 2 o'clock tomorrow. All right, if we've got no more last minute questions, we'll wrap it up. Thank you everyone for your time. Hope you have a good rest of your day.